Good morning, good afternoon, good evening, everyone. It's a pleasure to moderate yet the latest session in our keynote special series for the Hamlyn Symposium. And today I am delighted to introduce Pierre, a long-standing member and advocate for the Hamlyn Symposium. So Pierre Jannin is an Inserm research director at the Medical School of the University of Rennes in France, and the head of the Medicis research group. Pierre received his PhD from the University of Rennes in 1988 on multimodal 3D imaging in neurosurgery, and the French HDR from the University of Rennes in 2005 on information and knowledge-assisted neurosurgery. He has more than 30 years of experience in designing and developing computer-assisted surgery systems and innumerable accolades to his name. Amongst these, he has authored and co-authored over 100 peer-reviewed international journal papers, was the president of the International Society of Computer-Aided Surgery from 2014 to 2018, and has been an elected fellow of MICAI since 2018. And he is the co-founder of IPCAI, where he served as general co-chair from 2010 to 2016. Now, Pierre's research focus on surgical data lies in surgical data science, surgical robotics, image-guided surgery, augmented and virtual reality, modeling of surgical procedures and processes, surgical training, and validation methodologies, which are all perfectly pertinent to the symposium's broad topic areas. And today, I am delighted to introduce his keynote on surgical skills analysis, which I'm sure will be eye-opening. Pierre, you are now welcome to share your screen, and I look forward to your talk. Thanks.
Thank you, Ferdinando. Welcome, everyone. Do you hear me? Do you see everything? Okay, good. I'm very.
No, sorry, Pierre.
Yes.
Yeah, you have to share your screen because.
Again, okay.
Yeah, because I took it away when I shared mine.
Okay, we'll do it. We'll do it just now.
Perfect.
Is it good? Thanks a lot. Thank you again, and thank the Hamlyn Symposium for inviting me for this talk. Thank for you, also the audience, the participants, to attend this presentation. I saw that in the audience we have prestigious participants from all around the world. I don't want to give some names, but thanks for your attention. Some of you know already what I will say, but I try to put the last results of my research within this talk to update it, and maybe to explain the big picture. So I will talk about surgical skills and why it is important, and how can we use it and how can we do it. I'm just across the channel from London. Of course, I would have preferred to be in person in London as we are every day at the Hamlyn Symposium, which is in a wonderful location. But I'm here in Rennes, and we are not so bad in Rennes too. So for those who don't know, we are close to Mont Saint-Michel and Saint-Malo. So you are all welcome to visit us in Rennes. My team is located at the Medical School, Medical University. So I'm saying that because we are in the team both researchers from biomedical engineering background and also medical researchers working together, and more specifically surgeons. And we are all working together in a daily basis. What are the challenges we want to tackle? Of course, as everyone, we want to do better to what is done nowadays in surgery. We want to be able to tackle the challenges that we have in 2021. We want to operate earlier, to be less invasive, to reduce the adverse events that are well known to occur in the operating room. We will also need to face the challenges regarding to an increasing request of surgery with a population which is becoming older and older, expectation about the cost of surgery also that we need to address. And we also need to address the training of surgeons in terms of the fact that less experts are available for training and even for operating. So there are challenges we want to tackle, and It's the way that surgery evolved in this last century is that the surgeon started alone in front of the patient, working with few data, few information, few knowledge, and then progressively, where we are nowadays in the middle, we have a surgeon who is working with devices, with data and information and knowledge, but everything is separated. Where we want to go tomorrow is to go to a more integrated system, I would say, or computer-assisted surgical systems, where everything is connected together, data, information, and knowledge, and is working in a good collaboration with the surgeon. So the way we want to address that in our community is to rely on surgical data science. That's a proposal we emerged and we proposed to the community some years ago, and the idea is really to go from a state where the surgeon today has to integrate all the data and information by himself or herself, where for tomorrow, where the system will be able to help him or her to do this integration in order to ensure that this information is well understood and well understood and well used by the surgeon doing surgery. So what is surgical data science? What I say, the idea of surgical data science is really to integrate all the data, information, and knowledge that exists in surgery, but not only about the patient, but also about the other components of surgery that include the sensor, the effectors, and the existing knowledge. And effectors mean both the devices, the surgical devices, and all the human actors that are involved in surgery. So how surgical data science is willing to use all this kind of data. So it's the idea is to start by a collection, an acquisition of all data all along the surgical workflow. So preoperative, intraoperative, and postoperative, to collect everything and to analyze this data in order to extract from the data some information, so to build models. Once we collect enough models from a population, we can generate some knowledge. Of course, this knowledge can also come from an analysis of the literature or come from experts, which is a model-based approach. Then what we want to have is a way to instantiate these models of knowledge in order to generate new information for the surgeon to help taking decision during pre, intra, or post-operative surgical steps. What is interesting in this scheme is that the analysis approach is continuously fed by new data, which is collected all along the perioperative workflow. So what is really the characteristic of surgical data science is that you learn, so you create knowledge from learning. You can instantiate this knowledge to produce new information for a new patient, and you are able to produce information which is not directly coming from data, but which is coming from the instantiation of knowledge. And of course, a third important characteristic of surgical data science is that this process is an iterative loop where the knowledge is iteratively enriched and increased by new data, which is continuously collected. What is a very specific characteristic of surgical data science compared to biomedical data science, for example, is that the data does not only concern the patient, but it's also data about the effectors, data about the human actors which are involved in the process. So in this scheme of surgical data science, you have patient models and you have also effector models, and I will show you some examples. So why we do that? So why we want to include the effector models? And if I unzoom a bit, and I will come back to this kind of scheme afterwards, what we want to do, if I come back to the big picture, ideally, so we don't want to replace the surgeon, we want to augment his or her skills. So that this is our ideal motivation as developing a computer-assisted surgical system. So to be more precise, what we want to do is to reduce the variability between surgeon skills. So experts, we don't want to augment his or her skills, but we want to reduce the variability between surgeons. So how do we process? So the big picture is the following. So we will collect data from different systems. It could be in training setups, or it could be in operative and clinical setups. And we from this data, we analyze the surgical skills, and by adding some specific parameters, we wanted to see what are the relationship between the skills and the performance, the skills and the outcome, in order to ensure that we can improve the way surgery is performed by improving the clinical outcome, I would say. We will improve the way surgery is performed as an expression of an improvement of the surgical skills. So this is really what we want to do, and this is what I will illustrate through this presentation. So the two main applications we have in mind is really intraoperative application with assistance of the surgeon in the operating room, but it's also about using that research to improve training of surgeons, so to improve surgical skills training. What are these skills? So I'm talking a lot about surgical skills, but what are these different skills? What are the surgical skills? So when we read the literature, we can find a lot of papers explaining the skills which are involved in surgery. And what is important to have in mind is that it both includes technical skills and non-technical skills. So surgery is not only about dexterity, it's not only about having what people say, the hands of God. I'm sorry, my phone is ringing. It's something that may happen sometimes. So it's not only about the quality of surgery. It's not only about the dexterity of the surgeon. It's not only about the basic technical skills. It's well known. Indeed, there is a paper that explained that the quality of surgery depends on dexterity for only 25%. It really expresses that we need dexterity of the surgeon, but we need more skills than that. So other skills, the second technical skills is about the conceptual knowledge, so knowledge about the anatomy, knowledge about pathology, knowledge about physiology. Then another skills which is well known, which is between technical and non-technical, is what we call procedural skills. So it's some people call it procedural knowledge. A way to explain what is procedural skill or procedural knowledge is, let's consider that surgery is like a recipe. So you have to learn in which order you do things, and you cannot do things in a completely random order. So there is an order. And this order is something you have to learn, and you need to have in mind. Of course, in surgery, this order is quite variable, and there is a high variability, but I will come back to that. Then, what is important to have in mind is that the fact that surgery is not only about knowledge, it's also about human factors, because surgery is performed by a human, helped by a team of humans and these human factors are crucial in the success of surgery. So the first category of what are called non-technical skills is the cognitive skills, and the cognitive skills concern situation awareness, self-confidence, anticipation of risk. So there is a well-known list of what is considered as cognitive skills. And the second category of non-technical skills are the interpersonal skills. So the interpersonal skills are obviously important because, as I said, the surgeon is not alone in the operating room, and it concerns teamwork, communication, and leadership, for instance. So what makes an expert in surgery is really the combination of all these different skills. It's well known, of course, some are very correlated. There are not clear boundaries between the skills, but a surgeon needs to have all these different skills. What is important to have in mind is they are, of course, not all very well learned in our common and contemporary process of learning, and I would say at the university and medical school. So this is another challenge. So let's try to go skill by skill, and I will show you what we can do in this concept of what I say surgical data science, where we try to analyze the skills by using data which is collected during surgery or during a surgical performance. So the first example I want to show to you to illustrate this purpose, let's put ourselves in a very simplified setup. So let's consider surgery in a simulation setup. In a very classical, usual pick and place task, part of the fundamental of laparoscopic surgery tasks. And let's, for example, do this task using a master-slave robotic system, and let's collect the kinematic data from this during this task through this master-slave robotic system. So we can do that, and then we have data, this kinematic data we can analyze in order to understand how surgery, how the activities perform, and we can try to analyze some characteristics of the skills within this data. So just to give an example, we did it, for example, in a context of using an ultrasound simulation system. So we collect data from an ultrasound simulation system. We collect the kinematic data, and on this kinematic data, we are able to compute some features. It's easy to understand. We have features computed on this kinematic data, and we can do some statistics, for example, based on an a priori known level of expertise, novice, intermediates, and experts, and we can show that some of these features computed on the kinematic data are statistically significantly different according to these three levels of expertise. So we can do it on any kinematic data we have. For example, we are conducting a study on arthroscopy on an arthroscopic simulator. We collect the kinematic data as well, and we can do an unsupervised analysis of this kinematic data. And we show that by computing metrics on this kinematic data or distances between the kinematic data using a DTW, for example, approach, we are able to automatically cluster the different level of expertise in a very robust way. Of course, machine learning also could be put on top of that, where we can study the relationship between some of these metrics computed on kinematic data and some standards like OSATs, which is a well-known scoring system for surgical skill. And we can show that we can make correlation between this standard scoring system, which is based on observation, and metrics computed on the kinematic data. When we started to have that in mind, we can do and we can develop, we can propose as many metrics we have in mind, and we did several studies with a colleague of mine in order to compute different analyses of this temporal series, which are the kinematic data. And we are also nowadays trying to analyze more complex data, which are not coming from a simulation system, but directly coming from the operating room. For example, in that case, what you see here is a kinematic data coming from a Da Vinci system during an hysterectomy. Of course, we accelerated the data, but you see, for example, the two anatomical sites where the surgeon worked on during this first stage of this surgical procedure. Second skills that I talk about is the procedural skill. So what is well known in the community is also to call this procedural analysis as a surgical process or workflow analysis. So what is considered as this kind of analysis is that what was done initially, you had someone who was observing a surgical procedure, and he or she was encoding in terms of semantic what the surgeon was doing, which action he or she was doing, which surgical instrument was used, and which anatomical structure was used for this action. Once you have this description of surgery consisting of hundreds of small activities like that, you can develop metrics in order to compare the procedural skills between surgeons. So the idea, as I said, is to describe surgery as a recipe, a sequential list of activities, phases or steps. And ideally, what is important is to do this description using a standardized semantic. For example, what we propose is to use an ontology. So this ontology is freely available and can be used for that. The idea of and the advantage of using an ontology is that you use let's say a standardized vocabulary, and then you can share your annotation of surgeries, and you can combine descriptions coming from different clinical sites if you rely on the same semantics. So what you see here is how you describe online this recipe, this surgical procedure. Of course, you can do it offline if you video record the surgery. It gives you more time to do it, and you can be more precise in your description. And then what is the result of this description is, like you see here, it's a code bar representation of a surgical procedure. You can see surgery as a sequential list of activities, steps or phases. And once you have that, you can start computing metrics, distances between this kind of descriptions, simply by counting actions, counting duration of this action, phases and steps, or you can develop more complex metrics. For example, that's what we did by using DTW on this semantic approach. We extended DTW for using it to compare surgical workflows. And what we showed for the first study we did, which was a study comparing surgeries from different clinical sites worldwide, one in Germany, one in France, and one in Canada. And what we showed in this paper is that the descriptions of the surgical phases, steps, and activities were a way to automatically classify, expertise, and even to recognize the clinical site. So there were really dedicated ways of performing surgeries according to the different clinical sites, different recipes, I would say. So what we can say, even by studying this procedural dimension, we also demonstrated by studying the learning curve of a surgeon during 4 years. We demonstrated that you can also find this learning curve effect just based on metrics computed on these descriptions of surgical phases, steps, and activities. Again, we propose other approach based on entropy, for example, computed on this description, and we were able to demonstrate interesting aspects regarding the procedural dimension. So I will skip this one, but just to mention it very briefly, we can do it not only considering surgery as a whole, but also part of it. So studying what we call the sequential surgical signature of a surgeon, which consists of looking for small patterns of sequences that you can find across surgery according to expertise. So of course, what you have in mind, and what you probably can tell me is that it's a bit cumbersome to rely on observation which are done online during surgery or offline on videos. It's of course a lot time consuming. So what people are trying to do, and what we did also starting almost 10 years ago already, is to replace this manual annotation by an automatic recognition of this surgical activity, phases, and steps from sensors, for example, from videos. So one of our first work was to do a video analysis of a cataract surgery, and we were able to automatically, by using machine learning, basic machine learning approach, we were able to automatically recognize the main phases. And more recently, like other groups are doing, of course, we are not the only ones. I saw people from Italy in the audience, and who do that. People from Germany also who do that a lot. I saw Isabelle is attending here the meeting today. They are also developing a lot of very exciting approach on that. And so the community is really working a lot on automatic recognition of activities within video, in order to have this automatic annotation, I would say. What people are working a lot on also is to try to recognize the instrument and even to track the instrument within the images. It's luckily for us, computer vision and deep learning offered us a very powerful tools and very robust tool to be able to track things which are not so easy to track in surgical videos. And for example, not only activities but also events like smoke, recent work we did. So this automatic recognition can be done on video. So there are still challenges, and it's not fully solved yet. There are still research team working on that, and even ourselves, we are working on that. But it's now a question of improving the percentile, I would say, of accuracy and precision. What is interesting is that also try to do it from not only from video data, but also from kinematic data. So that's a work we did some years ago, demonstrated that we are also able to, we could also be able to recognize activities from kinematic data. So there are, as I said, there are still a lot of challenges. Try to improve the the performance because we don't have so many data in surgery. So how we can how we can rely on other data. So something we did some years ago was to help ourselves by using natural language processing from post-operative reports and papers in the surgical literature, and the word embedding in order to pre-train the networks and to improve. And what we demonstrated, we were able to improve by several percent the performance of our networks with this multimodal transfer learning scheme. What we are trying to do also is, can we do automatic annotation in the context of surgical simulators? And that's what my colleague Arnaud Volmé proposed recently, is a way to automatically annotate from surgical simulators where you have some basic data, and you can use this basic data to automatically, by using rules, to automatically recognize activities, steps and phases. Just an example to show you what we can do with this methodology in surgical training. For surgical training, so we can annotate videos, for example, of table preparation, surgical table preparation by scrum nurses, and we can compute for this annotation a graph representing the variability of surgery in terms of procedure, and we can use this graph to feed a virtual reality simulator in order to help scrum nurses to train and to learn complex procedure like table preparation that involve hundreds of surgical instruments and hundreds of actions. So I skip that. Let's try to give a last word about the non-technical skills. So I saw Marco in the audience too. So there are a lot of people, and he's one of the pioneers in the community that really put a focus on these non-technical skills, which are really important. And there is again an important set of papers in the literature that demonstrated how important are these non-technical skills. What initially the community did, and what we did also, was to try to tackle this non-technical skills by observations in the OR, and being able to demonstrate some individual profile regarding to interpersonal skills, and also try to emphasize how important they are. For example, how important are workflow description in surgery, which we estimated about around 10% of surgical time being workflow description. And since we know that there is an important connection between the workflow description and the success of surgery, there is really something to work on here. Now the challenge is to tackle this non-technical skills by using sensors, and this is what, for example, Marco is doing in a very successful way. So how this non-technical skills can be implemented in surgical training, for example. So we develop a different simulated scenario, VR simulated scenario, in order to help surgeons to, or in that case, it's more scrum nurses, to train situation awareness, for example, by developing the operating room of their errors. And another surgical, non-technical surgical skills that we studied was how we can train communication by using a VR system. So we try to develop it in a simple setup. What we did also recently was to study, can we implement it easily in another culture? And we studied how we can adapt our VR environment to a Japan hospital, for example, and we did some experiments of acceptability of such system in France and in Japan. and demonstrated that the results are very similar. And so these tools are indeed quite generic. Very last point that I want to address, which is, of course, when you study these different skills, surgical skills, both technical and non-technical, what is interesting is to start studying how they are related to patient data, finally to the patient dimension. So we just started very recently to study in the context of two dedicated studies, to study the relationship between some metrics computed on videos or on kinematic data and the success of surgery, success defined in terms of patient-related parameters. And so in the first study, what we tried to correlate was the exposure, the quality of exposure, and some metrics, some features computed from video, and we, by machine learning, trying to make the relationship between both. So we are not done yet. We are still a lot to do in this area, but we show the feasibility and the principle of this approach. And similarly, in another study that we had, where we try to study the relationship between adverse events in surgery and some data you can capture in video, and how you can model relationship between both. It's still a work in progress. So the correlation exists somewhere, but they are still need to improve in order to have useful tools for surgery. So here, what we try to do, so we collect data from simulated system or surgical system. We compute by analyzing the data coming from this system. We compute features related to the skills, which we have a quantitative analysis of the skills, and the idea is to by using machine learning, is to make a correlation between this information, the outcome, and if we are able to do it correctly, then we will be able to put it in another way. So to use this correlation to improve the way surgery is performed. So this is where is the challenge we want to tackle. We are not here yet. Considering that surgery again is a mix of different skills, considering that it's about not only about the way surgery is performed, but it also includes patient data, and considering that there are still a lot of challenges in this surgical data science approach. We need to have a lot of data, and we know how difficult it is in surgery with a high variability. We need to have a robust and rigorous analysis approach, and we still need to develop new approaches. And of course, there are other challenges, like we need to study how this kind of decision support or even action support tools can be accepted by the professionals. So there is still a work to do, not only about acceptability, but also about evaluation and also ethical challenges that I don't want to, and I don't have time to tackle now. In a more precise way, there are in aspect we are studying now is try to use a multimodal sensor to study these different skills. So not only video and kinematic data, but other sensors, other physiological sensors. How we can give a feedback? How can it be given to the surgeons? What is the relationship between what we do in the simulated setups and in the real clinical setups? Relationship with outcome. As you saw, there are still a lot of challenges to address, and there are still a lot of work for all of us. What is important to keep in mind is that all this development and this research is done in order to have a clever collaboration between the surgeon and the machine, between the surgeons, the humans, and the what we can call the artificial intelligence or the robotic system. We need to work together. There is no idea of replacing anyone, but really to have a clever collaboration for the benefit of the surgeon and for the benefit of the society as a whole. Thank you for your attention. I hope I was not too long as usual.
Perfect, Pierre. Absolutely perfect. Thank you very much. It was such a great talk. So I would like to encourage our audience to feel free to ask questions to Pierre via the Q&A tab, and I'll pose these questions to Pierre as they come along. And as our audience thinks of their questions, I have a ton. Yeah, I mean, machine learning and artificial intelligence are the perfect tools, right, to really sort of get machines and clinicians working better together. So I think we're all on the same boat. But I think as a user of this, but not as a specialist, right, the open question that always that remains in my head is that, because I sort of understand how these black box solvers work, yeah, there is this very difficult discrepancy between correlation and causation, right? And because I'm the son of a clinician, I know that a lot of the decision making that happens in surgery and outside is based on context, and it's based on things that are not necessarily visible or sensible, you know, right at the moment where that decision and that action is taken. So can you see a future where we will be able to capture that relationship, or so the full flavor of inputs that causes the clinicians to make a certain decision? Or we're going to move in the direction of everything is standardized, and now we're going to use tools to create workflows that are easier for a machine to then interpret and learn from, so that it can eventually be automated? You see what I mean? Is it we're going to move from art to science, and only then can all of this make it into the big leagues? Or do you think we're going to get algorithms that somehow can mine even the data that is not so readily available within the clinical scene?
So you expect my answer? It will be in between. It will be in between.
That's perfect.
And then I'm done. Next question, please.
Yeah,
no,
yeah.
Because the surgery, as I said, is very variable. So you cannot put everything in standard processes. It's not possible, and I think it will be a mistake. We saw in other areas, when you look to, I don't know, military area, or in power plants, or in very sensitive, or in airplane, in very sensitive areas, they went in that direction. They tried to standardize all the processes and make protocols, and they just have to follow the protocol. And then there was they came back to a mix of both, because you will have moments, you will have surgeries where things will not be like expected, and this is because we are dealing with life. It's not about only industrial processes. It's something different with healthcare. That's why sometimes people don't understand where they are not in healthcare, and that's why what we are all doing is very complex. Is we are dealing with life. We are dealing with random. We are dealing with unexpected events, and some of them really unexpected, unknown, and unexpected. And this is where the intelligence, the real intelligence, the human intelligence, will be important to use. I'm talking about the highest levels, where sometimes it's even called intuition or enlightenment. Sometimes you cannot explain the decision. There's something that came from. So it will be of course, I think we can consider that some aspect will be easy to standardize. It will be easy probably to give to the machines, decision and action, and to robots and to AI. But some of them, I mean, not some of them, but what is important to consider, that the human needs need to be still in the loop in order to be able to tackle these unexpected, unknown events that may appear.
But if I were to push you one step further, and I think there is, I mean, obviously it's a matter of opinion, but do you think that when it comes to the longer term future, as we turn what is currently as much of an art as it is a science into more of a science, so we instrument medicine to an extent that we understand those processes better and more mechanistically, would it then be okay to basically make it more of a standardized approach to healthcare, or do you think we'll never get there? Right, so the human body and pathologies are so complex that it's always going to be a human in the loop, sort of very, very human process as opposed to a very technical process. And I think I can personally play it both ways. I can see how you think one way or the other. And of course, again, with a lot of medicine in the family, it's endless conversation at the table as to whether it's science or medicine, you know, or not.
So again, as you said, both scenarios can be considered. There are different ways of answering your question. There is one way, which is I would say the engineer's answer, where I say yes, probably. I worked a lot in neurosurgery and especially functional neurosurgery, where you have stereotactic procedures, and this kind of stereotactic procedures put a lot of effort during planning. But once the planning is done, when you know where you have to put your electrode, I mean, it's almost done. It's almost done. It's a linear trajectory, and so probably this kind of procedures can be made automatic or with a high level of autonomy, probably high level of autonomy. There are robots already, but they are not so autonomous, but there are already some robots, and I think we can go further in that direction. So yes, we can consider surgical procedures where most of it will be made automatic. So that's the first answer, engineering oriented answer. There is another answer, which are probably and
more philosophical.
Let's say someone else will answer that. What kind of future we want to go, and what will be the future, knowing all the possible crises we have in mind. So we just faced a health crisis, and some people are also very aware about what could be a environmental crisis. So will we be able to progress still in an exponentially way with the technology without considering its cost or its consumption? Yes, or even how it is available through the world. So will we have two worlds, a very rich and automatic and high level healthcare, or another one which we know where we are nowadays, and let's consider it. So I don't know. I will say probably we can go very far with the technology. I'm not sure we will go very far. I mean, on that direction. Maybe we will find other ways to have a more, let's say, sustainable future, where we consider not only the technological progress, but also the progress of the society in worldwide, I will say. So this is where you see it with the sustainable goal developments of the UN, for example. So
the thing is, in my head, and having worked with clinicians for a number of years, is 50 clinicians, 51 ways of doing things, which are slightly different, right? And so the open question is it 51 ways of doing it a function of the fact that it's still more of an art than it is a science? And so training and experience, and we're going to get past it, and we're going to be able to standardize what is the best way to do it in that scenario, or it will always be too complex for that level of clarity as to what is the right thing to do at every point during a procedure.
No, when you discuss with surgeons, they say that already they standardize their gesture, and when you discuss with young surgeons, they would like to know how to make it, and they would like to learn faster, and they want to learn because there are some parts of surgery where there is almost no risk. So in that case, you have to be fast, and you have to
not tying. Yes, absolutely.
Don't spend too much energy and cognitive workload in this very and then in that steps, it's easy to learn protocols, and you do it, and you don't think about that, and you just focus your cognitive workload, and you keep it for when there are really sensitive and critical steps. So I think yes, we can standardize parts of surgery. Of course, a surgeon would be better than me to answer, but this is what came from discussions I had with surgeons.
So parting question for me would be, of all the things for which data science could help in terms of skill assessment and eventually standardization and automation or synergy between computers and humans, which do you think will come to the bedside in the widest sense sooner? As in, which aspect of everything that you're involved with you think has got the highest chance to benefit the wider clinical community in the short term?
In the very short term, I think in the surgical training, in the training aspect,
So outside the operative, so just basically
and people are ready and we have already, the systems are already here, so the data science approach can be implemented in the
no risk and no philosophical or ethical implications either, right? So it's just
and easier, shorter procedures under control, so it's easier. So that will be implemented very soon, probably. Then if you think about the OR, I think like stereotactic procedures and procedures that already use some robotic systems, probably. So all the master-slave systems, and there are already some very nice robotic systems that exist and which are used clinically. On that, we can use data science, and probably on that, what can be done in a first way, for example, is to constrain the surgical gesture by no-go areas or things like that. Or you can do augmented reality features that are easy to be displayed in the console. So this step by step, I think at a short term, we can have this kind of features, which will be based on data science.
And we have to find ways to facilitate various industrial players to actually share some of that data, because of course some of the data is readily available, but a lot of the data that will be quite instrumental in this is protected, and those who acquire it are rather secretive about it, which doesn't help. Pierre, it was a fantastic presentation. It was great to see you, even though we're in a virtual space. I'd like to thank our audience for taking the time to be with us. Remind everybody that this keynote will be on the YouTube channel, and that if you want to know what happens next over the coming weeks, all the way to our closing ceremony at the end of July, please visit www.hamlynsymposium.org, where everything is updated and there for you to see and review. So thanks, Pierre. Thanks, everyone. And I'll see everybody soon. Take care. Ciao, Pierre. Enjoy the rest of the day. Bye-bye.